Hey guys, so we're going to be taking the AP Calc AB practice test. This is from 2012. It's a public practice exam released by College Board, and so I'm not doing the whole thing, of course. That's going to take too long. It's going to be this one instead. Hey guys, so we're going to be One taking second. The AP Calc. Okay, and this is 28 questions, 55 minutes allowed. So let's set up a timer for that then. So 28 minute, sorry, 55-minute timer. Okay, I'll set that up. And then no calculator allowed, so I don't have one. I'll do this all online so you can see. And you can, so first of all, like I haven't done this AP myself. I've just learned some stuff on Khan Academy and outside of that. So don't have any high expectations on this. I just want to see how much I know, just, see. Yeah, okay, this stuff, like, not too important. And then no calculator 55 minutes. So let me start now actually. So I'll start the timer and then I'll let me check that my editing stuff is working. Oh, I should probably go to Microsoft Edge actually. This is It's not easy to edit these PDFs, right? It's like, yeah, wait, I will do that actually. So I'm just going to pause the stream and then get back to that later. Okay, yeah, let me just get it back now. I messed it up a bit. So there it is. Yeah, it should be visible now. Hopefully, I'll just take a minute and see. Make sure that it is. Uh, should be. Okay, just assume it's working. And okay, so this should be easy to edit on, at least easier than the other one. It's looking a bit different, the exam here, but obviously must be the same thing. Wait, it's still not working actually, so at least I can't see it over here. So let me. Okay, this works. This doesn't. Okay, it's working now. Great. So let's see. Now it's on. So everything should be working. I just want to check that you can even hear me because I'm not too sure. So just give me 1 second. I need to test something. Great. Yeah. So it's all working now. Now it's about time I actually get started. So let's go there and begin it now. So same stuff as before. Uh, we None of this is important, and this is where it begins. Right. This is where we were. So 55-minute timer. Let me check that now I am able to edit. Okay. What the hell? I can't edit it, so let me just download it and then um whatever. Let's just move this to downloads. I'm just gonna download it and then open that up. So this I should be able to edit. What? Okay, great. There are more issues now. So this is how do you do this? I'm not too sure actually. So if I download it, will I be able to edit it or not? I don't think I can. Right? This might be a stupid thing, but yeah, I don't think I can edit this actually. It's saying like file has limited permissions, you may not have access to some, and that's editing file content. Okay, so like what do they want me to do then? I can let's just find a new one then. AP calculus AB practice tests. Practice MCQ part, right? That's what we want. MCQ. Okay, so hopefully this should work. Now, if it's like, it might be hard for me to share my screen, then that's a problem, but let it be. Let's look at this first link here. We got this practice exam, multiple choice practice questions. Sample questions. I want like a full practice test. That's the point. So we'll see. Full length multiple choice part A. I think that's it. I won't have to sign up now, I'm guessing. Okay. There are 30 questions, so it's a bit off. 30 questions. The other one had 55 minutes for 28. So this will be like 59 or 60 minutes. The problem with this though is that I can't edit my screen, I think. I'm sure there are ways to do it, but I'm not going to figure that out. So let's just change the search and find a PDF now. I should have thought this through a bit more first, but we'll see. Okay, this is a PDF. Let's just look at this and see. Practice test 1. Okay, great. I don't care. I can edit this. That's all that matters. And okay, so this is very similar now to the previous test that we had. The only difference is that 30 questions and 60 minutes. So basically the same thing. I'll just change up the timer here. 1 hour. Great. Let me delete the other tabs. And now we can actually begin. All the same rules and the questions begin there. So I won't look yet. Reset. I'm starting the timer. So I'll like check periodically. I won't share both screens at the same time. I'll just begin now. And let me check first actually before anything that my like all my writing stuff is working. It is. So let me scale that all the way down and then begin. Great. So we can start. Timer has begun. And the first question is, if f of x equals 3x squared minus 10x plus natural log of this, find f prime of 4. So f prime of x, first of all, is just going to be what? 6x minus 10 plus 1 over x minus 3. So f prime of 4 is going to equal, so you're just plugging in 4, that's it. So 24 minus 10 plus 1, so that's 15, right? So the answer is D. Next question, limit as x goes to infinity. Very easy. So for anything like this, you just look at the leading term, cancel this out. Since these, like, they have the same degree, just look at the coefficients and the answer is 5/4. So C for this one. A lot of the stuff I might not know or just I might not remember, so expect that. Now for this one, actually, like, there are definitely fast ways to do this, at least I think so. Yeah, let's do it. I could use a quotient rule on this whole thing, but I just don't think that's a very sensible thing. It's a lot of work there. First of all, we can, unless I'm like being a bit dumb here, I think we can just cancel out an x everywhere, right? Like just write it out as x times 3x plus 1 over x times 3x minus 1. All this does is remove the value like x equals 0, so you can't have that value anymore, right? Because that will make this denominator 0, but I don't think it really matters. Or does it? Wait, I'm not too sure about this actually. You know what, let's just do it the long way and then see, because I'm not too sure about these technical things and I don't want to make a dumb mistake here. So let's write f of x as 3x squared minus x over 3x squared minus x. Obviously that's wrong, but now we can add 2x over 3x squared minus x, right? And this means this becomes 1, right? So it's just 1 plus this. So 1 plus 2x over 3x squared minus x. And because we've got this, the derivative, so this is f of x. F prime of x is just equal to the derivative of this, because derivative of 1 will be 0. So now over here we have 3x squared minus x squared. That in the numerator we have Oh, great. I think I've forgotten the quotient rule. I'm pretty sure you differentiate this one first. So it becomes 2 times 3x squared minus x minus, and now you differentiate this. So minus 2x times 6x minus 1. 2 what minus 2x, and then oh, yeah, I did this correctly. This becomes 6x minus 1. Okay, good. Just making sure. This does seem a bit wrong, to be honest, but I don't want to say that too soon. Um, Fine. So this becomes 6x squared minus 2x minus 12x squared plus 2x, which is okay. These cancel out fine. So we're left with negative 6x squared over um 3x squared minus x squared. Okay, I see. So it'll just be like you can take out an x squared from this, right? I'll do it over here in this area here. So it becomes negative 6 times x squared over x squared times 3x minus 1 squared. We are taking out an x twice because it's squared. So these cancel out, leaving us with this thing, which is c. Okay, so I think we could have just done this, the initial simplification, cancelling out the x's. Kind of dumb there, but I just wanted to be safe. Okay, the limit of this is 6 because, okay, let me show it actually. I don't want to spend too long, but so if you have sine of x over x, this is equal to 1, right? So if you have limit of, so sine of 2x over x is the same thing as 2 times the limit of as x goes to 0 of sine 2x over 2x, right? Because the 2x in the denominator and the 2 here will cancel out. So this is obviously 1, so it becomes 2 times 1, which is equal to 2 times 3, 6. Here, oh god, okay, sine of this, so find d by dx. So left, we take the derivative with respect to x, you get d by dx on the left is equal to, now we take the derivative with respect to x, which means, wait, how do you do this actually? This is fine. Right, Riemann sum. Okay, these seem a bit harder actually, so I don't fully remember how to do this. So let's try it anyway. Of sine of xy. So how do you do this? Well, we can say this will be, okay, wait, it's the derivative with respect to x of xy times d by dx. That's all d by dx. This times the derivative with respect to x. Sorry, no. With respect to xy, basically this becomes cosine of xy. Okay, just to do that. Derivative, okay, now this I do remember, thankfully. This will just be y plus x dy dx. And then all of this is multiplied by cosine, right? It's all multiplied by cosine of xy. This is equal to dy dx. So obviously we want to, really isolate the dy dx. That's the point of this. This is a bit untidy. Let me go down. I'll write a bit smaller now. Okay, just for the sake of space. So dy dx is equal to, now here we've got y cosine of xy, cosine of yx, whatever, plus x cosine of xy times dy dx. So if we subtract this here, we get dy dx. Now this is a bit might be a bit long of a step. Minus x cosine of xy is equal to y. It's not a long step actually. It's easy enough. We get this. Now to isolate dy dx completely, well, it's easy enough. Just divide, obviously. So we got y cosine of xy divided by 1 minus x cosine of xy. I hope that's an option. I don't know if it is. Y cosine of xy over 1 minus cosine of xy. I'm not going to be checking these answers, by the way, because I don't. Okay, let's check on the timer. 52 minutes left. Yeah, we've done everything so far, right? Yeah, okay. Now question 6. Using a right Riemann sum with 4, whatever, approximate this. So right Riemann sum means we go with 1, 2, 3, 4. Those are our values. So wait, what? We just plug this, and so it's like just use rectangles, right? The width will always be 1 because it's 4 over 1, and then the height is just going to be like the value. So you can do 3x squared plus 1. Basically, just call it f of x. F of x equals this. We need to find f of 1 plus f of 2 plus f of 3 plus f of 4. So this is like a bit of calculation, but easy enough. If you put in 1, you get 4. If you put in 2, you'll get, so this will become 12, 13. If you put in 3, you'll get 28. And if you put in 4, you'll get, what's it going to be? It's going to be 16, 48, 49, I think. I should be careful with the math actually, just to make sure. Well, okay, it'll be 1 more than a multiple of 3, right? We know that because this will always be a multiple of 3. You've got plus 1, plus 1, plus 1, plus 1 4 times. So it'll be 1 mod 3. So that means it won't be 95. It won't be 45. It'll be 94. I'm guessing if you just add it up. Yeah, 94. That's the sum. So let me clear this stuff. Keep this area a bit clean. The answer here is 94. So it's just going to be this. I don't know what this is, but let's take a look. Oh, okay. You need to find h prime of x and then plug it in at 2, right? So we can just say that, well, we can just say that g of 4x equals a, b, c, d, e, f, g, h, I of x. This is like basic chain rule. At least I'm hoping it is. Oh no, it's not chain rule. Sorry, it's product rule, right? Oh wait, well, if it's product rule, you can just like look at this and figure it out, I think. Unless I'm being like dumb here. Yeah. So it won't be either of these. It won't be A. It won't be D because this has to do with the product rule. So there's a sum involved. F prime of 2, you're alternating the primes. The only difference is there a 4 here because you're doing G of 4x. That requires a chain rule. Well, like normally I don't think of it as a chain rule, but the 4 will come out because you're taking the derivative of a function of 4x. So you have to take the derivative of 4x, which is 4. So this one should be B, just from like pattern recognizing or whatever. Moving on here, normal just means perpendicular. So just perpendicular to the graph of this. You need to find the slope basically and plug in the point. So slope, wait, this one, not sure if this will work, but we can just like plug in and see which ones, if these even satisfy. Okay, we're getting carried away. Just find d by dx basically. That's it. D by dx equals the derivative. Okay, square root of 3x squared plus 2x. So what is that? Well, that's just going to be chain rule stuff again, I think. So take the derivative of this and plop it. This I want to do a bit in my head, like partially. So the denominator will always be this, and then the numerator just becomes like the derivative of the inward thing here, which is 6x plus 2. The 2 cancels out, making this 3x plus 1. Okay, so 3x plus 1 over the square root of 3x squared plus 2x. Thank you for whoever's watching, by the way, because you're my first consistent viewer in this stream for quite a long time. So thanks for that. And now we just plug in 2 and 4. So what does the numerator become? It becomes 7. Denominator will become, I'm guessing it's 4 then, but I'm not sure. 2, this becomes 12 plus 16, 4. So the slope we found to be 7 over 4. Which of these have a slope of 7 over 4? Well, this is easy. Well, actually, this we didn't even need to do because very dumb that I did all this work. See, all of these will have negative slopes, right? You have to move they all have negative slopes. So it's obvious that it has to be B because this function doesn't have a negative slope. So it's that one then. What the hell? Okay, if it's multiple choice and they've given you the option, then just do it, I guess. What is the derivative of cotangent of x? Not too sure. So what is cotangent of x? That's just cosine x over sine x, right? So take the derivative. Wait, I take the derivative of this, which will give you over sine squared x. You'll get something in the numerator here, which should be, wait. So it'll be negative sine squared x minus cosine squared x, isn't it? Right? Because the minus the derivative of sine x times cosine of x, which becomes negative cosine squared x. Negative. So this becomes negative 1 over sine squared. Yeah, so this is negative cosecant squared of x. So this one, wait. So this is equal to negative cotangent squared x. To get the 4 times the positive thing, you have to multiply it by negative 4. So it becomes negative 4 times cot x. Oh, sorry. So this is wrong. Cosecant. That's what I meant. Cosecant squared x. So 4 cotangent of x. Negative 4 cotangent of x plus c, obviously. So a. Let's check the time quickly. 45 minutes. So we're doing decently, I think. Great. Now this one. Well, we again chain rule stuff, I guess. Take the derivative of this. So it will become the derivative of cosine of x, which is negative sine x, times 2 cosine. Wait. Yeah, 2 cosine x. So this becomes negative 2 sine 2x. Well, actually, why even write it like that? Wait, is that correct actually? No, not negative 2. Sorry, stupid mistake there. This just becomes negative 2 sine x cos x. So negative sine of 2x. I know that sine squared x is the derivative of that is sine of 2x. So does this make sense? Yeah, it does, because it's 1 minus sine squared x. So anyway, yeah, this is correct for the first derivative. So we need to now differentiate this one too. This is a bit irritating, but fine. Well, what will this give? Oh, wait, this is easy actually. Take the derivative, so you get negative 2. Very easy to just take out the 2. That's kind of the reason why I did this. Negative 2, so that comes out. Times the chain rule on this. Yeah, so negative 2 is out. Derivative of sine x is just cosine 2x here, obviously. So we've got this. So now if you plug in pi to this, pi cosine of 2 pi, right? Because it's 2 times pi. 2 pi, that's 1, so negative 2 times 1, which is negative 2. Okay, I don't want to spend too long on this video, on this stream actually, so I won't. 44 minutes left. Good. Wait, this is like very easy. I don't know if there's a prime missing or something, but fine. This is easy enough. 1, 3. That's it. Just plug in the values. For f of 2, this becomes 1. For g of 3, 3. So that's very easy. This one, oh no. Oh wait, this is u substitution, I forgot. So 1 plus x squared, let's say this is equal to u. Then what do you have? You have the integral of first of all, this means that du equals 2x dx. So we have du here, but we've got 1/2 du. So we'll take out a 1/2. So you've taken out a half, right? So this becomes just x dx. We've got x here, we've got dx here. So that becomes du. And here we've got the square root of u. So root u du. Root u du. That means it's u to the 1/2. So it's 1/2 times u to the 1/2 du. This becomes 2/3 u to the power of 3/2, 1/2 times this, plus c. C goes in or out, doesn't matter. So this becomes 1/3 u to the 3/2 plus c. Plus c. Obviously this will become half c, but it's a constant anyway, so you can call it whatever you want. So I'm calling it c here again. And with this, we know it's going to be, the coefficient is 1/3. And then, yeah, blah, blah, blah. That's correct. So it's a. But like, if I'm getting anything wrong, like, don't be surprised, because I'm no expert on this stuff. So it's very possible. Don't. If you think I made a mistake, write it in the chat. Okay. Speaking of chat, yeah, there are no messages there yet. Okay. The slope of the line tangent to this graph at 2, 1 is what? More implicit differentiation, I guess, right? So fine, differentiate the whole thing then. You get, so this one becomes 6x plus 5 over y dy dx equals 0. And oh wait, perfect actually. This is a nice thing. So add 2 comma 1. That's the point we're given. That does work, right? Plus 0. Yeah, obviously. It's 5y dy dx. So now you can move that. Wait, actually, yeah, we just want to isolate dy dx, right? So we can basically subtract it. So we got 6x equals negative 5 over y dy dx. Now we multiply it. So we got 6xy, negative 6xy over 5. Right? 6xy divided by 5, and then the negative goes there. So this equals dy dx. What's the slope? Oh yeah, there's no equation needed, just a slope. So now we just plug these points in. And when you multiply them, you get 2. So negative 6 times 2, negative 12 over 5. A. Great. The equation has a I've never heard of a fundamental period. So, uh, what? Pi over 4. So if you're multiplying it by pi over 4, it's what's the formula? I forgot. Let's just write it like this then. Sine of pi over 4 x minus pi over 4. We don't care about this. We just care about the coefficient of x when we're looking for periods. Sorry about that. And wait, so if you make the value of x, it's always 2 pi over that, right? So if you make it 5x, the period will actually shrink. Yeah, so you do 2 pi over 4, which is 8. 8 is the answer for the. I'm assuming. I don't know what a fundamental period is. I know what a period is. I think they're the same thing. I hope they're the same thing. Okay, now we're like almost halfway done. We've got 40 minutes left, so that's fine. At which point is f continuous but not differentiable? Okay, here it's obviously not continuous. Everywhere here looks fine. Here it is continuous, right? We've got that dot there. These things, it's not continuous. Basically, it's B, right? Because I'm guessing. Again, nothing that I say here is like guaranteed. Anything could be wrong. So if you think otherwise, write it in the chat. I might not like use it because technically that would be dishonest or whatever, right? I want to just see how much I know. So this is how we'll do it for now. Now, basically, it's you can't differentiate this sort of thing. You know, those sorts of points. For what value does it have a local minimum? Okay, this I actually have been studying recently. So you take the first derivative, which will give you 3x squared minus 18 x minus 120. Take out a 3, so x squared minus 6x minus 40. And how do you factor this? This stuff. Oh, wait, okay, x minus 10, x plus 4, right? So obviously to have a local minimum, it has to be out of these 2 points. But actually, I should be careful. Who knows? Maybe I've factored it wrong. So negative 4 will be 1. X equals negative 4. X equals 10 would be 1. So x equals 10 works. X equals negative 4 works. So this and this do not work. These two don't work. At least I hope. Oh no, then you can take the second derivative test. If the second derivative is positive, it will be a local minimum. We'll do that in a second. Let me check that I factored it correctly. 3x squared minus 18x, yeah, minus 120. X squared minus 6x minus 40, correct. X minus 10, x plus 4. This will add up to negative 6, multiply to negative 40. So these are the roots. Okay, that's done. That's correct. Local minimum. Well, so we want a local minimum, right? That means, yeah, second derivative test. So this is the first derivative. This is 1/3 of the first derivative. Doesn't matter because we're just looking for the sign, right? That won't change anything. Everything's been scaled down by 1/3. Okay, we take the derivative. We get 2x minus 6. That's it. At 4, this is. Wait, what? It seems to be. Unless I'm being a bit slow right now, or sorry, a bit stupid right now. This seems wrong. Because 6x, so whether you put in 4. Oh, sorry. X equals. Dumb mistake here. Silly mistake here. X equals 10 doesn't work. X equals 4 doesn't work. X equals 4 doesn't work. So these two do work. Negative 4 will make this negative, which means it's a positive, which means it's a maximum, relative maximum, whatever. So the answer should be 10 because that will have, yeah, 10. Okay, good. Wrong. Great. Done. Sorry about that. That was a bit bad, I think. Not too good. Acceleration is given by this. If the velocity is 10 okay, good. This will be fun, I hope. So this becomes 2t squared minus 12t. Dumb mistake there. Minus 12t. This becomes v of plus c. So this is v of t. Wait, and if you're plugging in 0 and the velocity is 10, that just means that it's plus 10. That's a constant. And the position is... Wait. Particle is changing direction. Not. If the particle is changing direction, what does that mean? Well, what does that mean? Well, isn't that like an inflection point or something? I'm pretty sure it is. Let's test t equals 5. Okay, let's actually just find x of t, right, or whatever that distance is, because the position is 4. So p of t, x of t, whatever you want to call it. It'll just be the integral of all this. So it'll be 2/3 t cubed. Now this is where I might make some mistakes, of course. So 10t, and the position is 4, so plus 4. This is the function of the distance. Just so you know, that's what that is. Now, okay, I'm just looking ahead to 18. Let's check the time now. Now we're halfway done. We've got good amount of a time left, 35 minutes. So that's fine. This is x of t. Now the particle is changing direction. So if you're changing direction, if your velocity is positive and the acceleration is... So wait. Basically, this is when does the acceleration go from... One second. I accidentally touched some paper with my foot, book with my foot. So basically, the velocity is changing direction. Velocity is changing sign, right? So if the velocity is changing sign, you're going from forward to back. So the velocity has to change sign. And we've got a velocity right here. That's all we care about, right? That means that the particle is changing direction. Fine. I think this is just a wild goose chase, like a red herring or whatever. We don't need this. This is what we need. We need to find when this hits 0. We can factor out with 2 immediately, which will give us t squared. Again, the reason I'm factoring it out is because it doesn't change anything. So what is this? T minus 6t plus... Wait, what? T minus 5, t minus 1. That's how this happens, right? And obviously it will change sign at both of these because it's a parabola. Parabolas don't just stand around over there. So the particle is changing direction at both of these, t5 and 1. Yeah, that wasn't a good question. I mean, question is fine. I just did stupid thing. What's the area? Oh, God. Next question is already looking a bit bad, but let it be. Okay. What's the area of this region? So first we need to like kind of figure out when they're even equal. Which will be I don't know if I'm just see, since these are two parabolas, so they'll be meeting at, I think, x equals 2 and negative 2. So x equals plus minus 2. These are going to be the intersections. So we just integrate from negative 2 to 2. Which function is on top? Obviously the function on top will be 12 minus x squared. So it's 12 minus x squared. You're finding the distance between that and 2x squared. So the height between them, which means minus 2x squared dx. So this becomes 12 minus x. What am I doing here? 3x squared. Well, ironically, that will be useful later. What I just wrote, x cubed, but not yet. This is what we have now, right? That's what we have now, right? We need to find the value of this. Obviously, 12. It will just be 12x, which means 12 times 4, so 48 minus x cubed. When we're doing minus x cubed, okay, let's not do this actually. This is what we have to do now. So 12x. So I've integrated this now. Like these are the bounds. So 2, negative 2. When you put in 2, you get 24, right? 24 from here minus 8. Now you do minus, and now you put -2. Here you get -24 minus -8, which means +8, which means this becomes like what, 48 minus 8 minus 8, 48 minus 16, 32. Done. This one I'm a bit worried about, but actually I don't think there's reason to be, because see, if you what happens if you 3 natural log of x, right? What does natural log of x mean? It means 1 over x. So can't we like integrate this stuff and just check it out and see if it works? So first of all, this one with a constant in it, that's just stupid. That won't work. And when you do this, you won't get the right answer. So it's not, I'm not marking this as my answer. In fact, let me use red for this, just to show that I'm serious about this. So A is wrong. Yeah, I'm just actually going to solve this stuff here. Oh wait, these seem a bit hard actually. X to the fourth over 4, like I'm actually a bit sorry. I don't know why I'm being like this right now. E to the e to the natural log of x just means 3x, right? Like, isn't it literally just e to the 3x? Or oh no, sorry, it's just 3x. Oh, not my proudest moment here. No, wait, I'm being like, this becomes x cubed, right? It's e to the natural log of x cubed because you can move the thing in there. E to the natural log of, which means it's just e to the natural log of x whole thing raised to the power 3, right? E to the natural log of x, this just becomes x, so it's x cubed. That was horrible what I just did. This is what we have now, guys. So or well, one person. Thank you for watching. If you're here, this just becomes, so the first term becomes x cubed, this one becomes e to the 3x, and now we just integrated normally. So this becomes x to the 4th over 4. There's only one that has that, so it's not this, not this, not this, it's this one, d. That's it. That's all you have to do, just e to the natural log. I didn't draw that connection in time. This one is I don't want to do this, but so f of x equals this. Find f prime of 0. So for this, we have to actually do a lot of work for this, it seems. Is there a shortcut? There might be. Hopefully there is, but I'm not sure. We can just normally like do the normal product rule stuff, but if that's whether that's ideal or not. Okay, let's try it. We'll see. If it's too much, then we'll just not do it. Okay, so first we'll take the derivative of this, which is 2x plus 1, and then we multiply it normally by this. So x cubed plus 5x plus 121. And then we add, we basically do it the other way around. So x squared plus x plus 11 times the derivative of this. Luckily, I know this, like just the general form of these derivatives. This is the chain rule. Now we're using the chain rule here. Okay, this becomes x cubed plus 5x plus 121. This becomes a derivative, which means it's 3x squared plus 5. We've got all this. Oh, that's the thing. This is our derivative now. Now we just plug in 0. So literally all the x terms go away. This becomes 1. This becomes 11. So this becomes 11 plus. This becomes 11. This becomes 5. This clears out to become 22. So 5 over 22 plus 5 over 22. 22 times 11 is 220, 242, 242 plus 5, which means 247 over 20, wait, what? Over 22, right? Or shouldn't it be over 22? Or did I just do something like, oh, sorry, it's 11 times this. Wait, let's rethink this then. I think that's wrong. Yeah, I think that's a trick. Let's slow down a bit. I think we got the 11 part right. This is just 11. This becomes plus 11 times 5 over 22. Or basically, yeah, cancel. So 11 plus 5 over 2, which is 27 over 2. Good. That's one which I easily could have made a silly mistake on. I was about to select that. So I'm glad I didn't do that. Okay, the question wasn't hard then. I guess you just have to do the work. Hmm. I don't want to do this really. I know. Wait, actually, I know the formula. I don't know why I'm worrying about it. So it's first of all there should be a three in front somewhere, right? Basically, we can write this as 125 to the x. We can definitely do that, which would mean that the derivative of this is 125 to the x times the natural log of 125, which is equal to this. So A does seem right. This is not okay. Think about it. If you're dividing it by the natural log of something, when you put in e, it'll just become e to the x. It simplifies to that. This is like the derivative of a to the x, and I'm pretty sure this is just a to the x natural log of a. In which case, we can make this 125 to the x, so it becomes 125 to the x natural log of 125. The only one that matches, so it's not this, not this. Only one that matches is a, so I'm just going to select a. We're doing well now. Oh, this is a problem. I don't know this stuff. 26 minutes, so we are like kind of crunched for time. Only 30 questions, so let's lock in. Um, let's lock in on this. I don't really remember this, but well, actually, I do remember this. Y equals x squared plus 1. The line x equals 1, the x-axis and the y-axis. So let's actually try to draw this a bit. I can't draw 3D stuff actually. So basically x squared plus 1, what will it look like? It will look something like this. Right? And the line, so the line that we're using is x equals 1. The x-axis and the y-axis. So it's like this section over here. Obviously, okay, yeah, so this section on top is infinite. It's just going to be this section right here. Oh, and it's revolved about the x-axis. So first of all, I know that you square something in this, so it's going to be this or this, because I've got the sixth power, so it's not c, not a. Pi goes in front. All I don't remember is, so when you revolve it about the y-axis, is that when you use the x coordinates, or do you use the y coordinates? And that's what I don't, because see, yeah, this is going to be at 1 comma 8. So either we integrated from 0 to 1 using this part, or 0 to 8 using this part. I just don't remember which one matches with which. I want to guess that it's simple. Rotating it about the x-axis. Sorry, I'm going to guess that rotating it about the y-axis means you take the x things. Well, actually, let's think about it. We do have like some luxury. Well, no, not really. We've got 24 minutes. Let's spend like 2 minutes to really think about it. What are we? What do we need to find? We need to find like the full volume, right? This is like one cross section. How many of them are there going to be? Sorry, we need to like. Okay, wait, what's the formula? It's like pi r squared. So we square this and we multiply by r, and then we're well, yeah. That seems like that's it. And when we're rotating it by r, we will be using x. So since we're rotating it by x, I guess we're using this. So I'm going to say b. Whatever I said right now, it wasn't very elaborate, wasn't articulate, none of that. I know it isn't like a very good explanation. I'm just guessing. It's very possible that I'm wrong. Now this one is not too fun, but we'll do it anyway. Yeah, actually, this seems like very doable. We need to basically use L'Hopital's rule. I'm like 99% sure that's what you do here. And you take the derivative of the numerator and denominator. Denominator derivative becomes, first of all, yeah, it is indeterminate. It's what, 0 over 0. Denominator derivative is 1, so we're just left with the derivative of the numerator, which is just going to be the derivative of sine of pi over 2 plus x. Pi over 2 plus x, what does that mean? So if you're here and then you went there, that's like, I'm pretty sure that's cosine of negative. There's some property for this. I think you can write this as something else. I'm not too sure this, so I'm just going to use the formula. So that means sine pi over 2 cosine of x plus cosine pi over 2 sine x. Okay, right? Or did I do that wrong? Okay, but I'm also low on charge on my computer now, so we'll see how to do this. I might have to like 2% away from time. and that will be bad. So, okay, after this question am I going? So sine of pi over 2, cosine of pi over 2 is 0, right, times sine of x. So sine of, okay, let's just check this you once. Sine of pi over 2 times cosine of x. That's correct. And then you add cosine of pi over 2 sine of x. Cosine of pi over 2 is 0, so you're just left with this. Sine of pi over 2 is 1, so it's just cosine of x. But I thought this one becomes sound stupid, but sine of pi over 2 minus x, isn't that cosine of x? I feel like I'm doing something wrong here, but I want to guess not. I want to guess not then. You know what else we could do? We could say this is where it gets a bit irritating, but we can say that this is the limit as x plus pi over 2 goes to pi over 2. Right? That's the same thing. Now this becomes sine of x plus pi over 2 minus 1 over, okay, I'm going to pause the timer. I'm getting it now. I don't want it to die. I'll also have to go down and get it. So I'm just going to. Okay, I'm back. Well, I just need to plug it in now. Thank God. Okay, done. Done. So it should like survive now. One sec. Okay, great. Where's my mouse now? We'll continue now. Back where we were. Right here. This is where it gets a bit irritating, as I said, but it's fine. We should just call this y, but we leave it like this for now. This is x plus pi over 2 minus pi over 2. We take the derivative with respect to, we can take the derivative of this with respect to x plus pi over 2, treating that as a new variable. So I'm just going to do that like this right here. Okay, so we're treating it as a new variable here, x plus pi over 2. How, and if you're differentiating this, so we can treat this just as like, okay, let's make it a bit easier. Let's call it y. So it's basic same thing as limit as y approaches 0 of, as y approaches pi over 2 of sine of y minus 1 over just y minus pi over 2. If you take the derivative of the numerator and denominator, right now when we take the derivative, the numerator will just become cosine of y, the denominator will just become 1. So it becomes the limit as y goes to pi over 2 of cosine of y. And when you take this limit, finally cosine of pi over 2, you just plug that in, that's 0. So the answer should be 0. If I somehow mess this up, then that will be like very sad, I guess. But I think it should be fine. 22 I also might have messed up. So things aren't going too well now. But we'll see. Okay, this is like, what's it called? This is ugly. You have to basically solve it. And so this is a differential equation where this is a, no, why am I saying partial differential? This is you can do it separable, yeah. First of all, 19 minutes left, so we need to go a bit faster. Separable differential equation. So we can say y dy is equal to, ignore that third line, 3x squared plus 2 dx. Now we have to integrate it. When you integrate it with respect to, basically you just integrate each side. So here we get y squared over 2 is equal to, this becomes x cubed plus 2x, and then plus c. It goes there, right? That's where the c goes. You won't put it at the end, you'll put it now. Basically, yeah, there's a c here as well, call it c1. Call this C2. When you subtract the constants, you just get one constant there. That's why I've just left one. Okay, now let's continue from here. Now you multiply it all by 2 and you take the square root. So it's a square root of 2x cubed plus 4x plus some other random c. Whatever c is, doesn't matter. Now we need to actually find c. Y equals 4 when x equals 2. That means that this entire thing is equal to 16 if you plug in 2. If we do plug in 2, this becomes 8 times 2, 16 plus 8, 24. 24, so c equals negative 8. So it's a square root of 2x cubed plus 4x minus 8. I just want to get that out there before I forget. This is now our new function. So now when we plug in x equals 3, what do we get? This becomes 2754 plus 12 minus 8. Plus 12 minus 8 plus 4, 58. So plus minus root 58. Great. Okay, done with that now. By the way, whoever's been watching, I'm assuming it's the same viewer. Thank you so much. I think this is the longest anyone's been watching consistently. So thanks. Oh, okay. And now, wait, no. This question now. This is probably like this is a very good question because I've done this same thing again and again, a lot of times. So what I'm pretty sure it's this, just off the bat, because when you, so this is basically off the arctan form, right? This is 1 plus x squared. Yeah, that's it. So this is equal to arctan of x, so tan inverse of x plus c. If you now, so what okay, wait. They've put in, isn't it 1/9? I think of 1/9 goes out, but that, well, then this wouldn't be 1/3. So basically take out a 1/9, right? You can take out a 1/9, which leaves you with 9 plus x, 9 plus 9x squared. Oh, wait, I think I'm doing this wrong. I'm basically from the formula, I'm pretty sure the answer will work out to be this right here. 1/3 tan inverse of x over 3 plus c. Like, pretty sure it's that. If not, then I'll have to study a lot more because that'll be bad. This one now, that should be easy. So first of all, this is just the chain rule actually, right? Pi plus 1. This is basically just like finding the thing and plugging in pi. We don't have to actually solve anything. Cosine of x. So when you do the chain rule, you'll get 3 cosine squared of x plus 1 times the derivative of cosine of x plus 1, which becomes negative sign. So it'll be negative, which is this. And then you can plug in pi wherever you need, which will work out nicely. Done. God. I think this is going to be integration by parts. Not too sure, but should be. Right? And in this integration by parts, we have to do x plus 3. So, okay. Okay, so it's going to be x squared over 2 times the square root of x plus 3 minus the integral of... No. We need to first integrate. How do you do it? I'm not going to write the rule because I never remember it like that. I remember by you integrate one, you differentiate one. There's also something called Liate or Liate, which is a trick to like memorize it, but I don't know that either. So we need to differentiate this in the end. So we need to differentiate the x and just remove that. So we just have the integral of x plus 3. To get to a situation like that, we'll write, first of all, we'll keep the x over here and we'll write the... Let's actually find it first. We need to find that anyway, so it makes sense to just integrate that. We're going to begin with just doing this, okay? TLDR, this is what we're doing now. We're doing this. This means that it's going to be 2/3 times x plus 3 to the 3 halves. Now we multiply this by x and then we subtract the derivative of x, which is 1, times this. So we just subtract 2/3 x plus 3 to the 3 halves, which seems wrong. Doesn't seem to match with any of this. Why is it 2/5 over here? That's my question. That doesn't make sense to me. Oh, is it because... So we integrate this, and when we integrate it, what do we get? No, there is some 5 halves thing, I'm pretty sure of that. So okay, let's actually do this now. Well, okay, if we take the derivative of this doesn't seem to work out, right? Let's just resort to that now, I think. And just see from this one seems pretty close to what we have, but it still seems wrong. It is. And let's check the time. 13 minutes, 12 minutes. So we're running low on time now. We'll have to speed run this. Let's actually just try it and see if it seems right. This one won't work. This will all cancel out to just give you x plus 3. So it's not this. Nor this one won't work either. This will give you a factor of x plus 3 to the 3 halves, which we don't want. So it's not this. This one will give us and again, this one will give us like 9 halves times something. This also seems wrong. So I want to go with D on this. If we have to, we can come back. I want to star this question for that reason, to come back if need be. Oh God. Okay. Natural log of this. How do you do composite functions? Chain rule, right? So natural log of. Wait, no, we don't need to worry about this. First we. Oh, the screen paused. It's back now. Wait, my stuff is here, right? Okay. F prime of x. So like it'll be 1 over natural log of 1 minus x. Okay, wait, something like horrible is happening right now. I don't think you can. It's like pretty hard to make this. Okay, it's back now. It's like working very slowly on my end. Like I can't see my annotations properly. So let's just pray for the best now. Okay, we've got the denominator 1 over natural log of whatever, and then we multiply it by this thing here, right? If you do this, it just becomes 1 over 1 minus x times times the natural log of x. So when we did 1 minus x, when we did the natural log of that, not only is it like 1 minus x, right? I'm pretty sure there's a negative in front, right? Is there not? See, because if we did negative x, you just do. I think we've already accounted for that actually. Do we have to, like, I think there is a negative that goes in front. See, it'll be, so this becomes 1 over the natural log of this. This will become, we need now the derivative of the natural log of 1 minus x. So yeah, we do this times the derivative of this. Okay, negative. There is a negative. The only one with a negative that matches this form is D. So D is correct. 2 more questions. You need to hurry up. Perfect. Not perfect actually. I don't know how hard or easy this is. If you plug in 0, you do get an indeterminate. If you differentiate it now, you get e to the x plus, I don't know if this is a L'Hopital's rule thing, but I'm not too sure. Wait, let's do this. Oh, this one is very easy. Okay, tan of x, call this u. So that means that du equals secant squared x. We've got that like right in there. So you just get u to the 6th du. Integrated, you get u to the 7th over 7 plus c. Tan to the 7th over 7 plus c. Perfectly matches. Done with that. Nice question there. Which leaves us with 9 minutes for this last one. So no worries at all. If we have to, we'll check the other ones. But to be honest, I'm not really a fan of ever checking my work. It's a bad thing, obviously. In fact, just today I was taking my English, like I had my final a few days ago for math. I got 24 and 25 on one part, and I got 8 out of 20 on the other thing. I'm pretty sure you just inputted it wrong. I think I got an 18 out of 20, but I'm not too sure. So anyway, yeah, this seems easy actually. I think we'll get some nice cancellations because when you take the derivative of this, you get negative e to the x. Right, we've differentiated the numerator, denominator, cancels out too. But all the limit stuff like that still holds. Like you still got all this stuff here. Okay, let me write it here as well. Cancel out this stuff everywhere. We get 1 plus x over negative 1. When you go to 0, this just goes to negative 1. So that's our answer. Now, I should check all my work here once or twice, but I think when I'm explaining it out loud and that sort of stuff, I tend to catch my errors. Let's check if they've even got the answers. I don't know if they do. Okay, we're done. Let's pause the timer. 8.5 minutes or so left. I want to now find the answers and check. I'm expecting like a very poor score on this. Okay, so oh, they don't have the answers, right? Wait, seriously? Do they not? Wait, they don't have it. Great. I don't know what to do now. I was like expecting that they have the answers. If they don't, then I'm cooked, probably. Let's see, maybe they have it somewhere else, right? Let's find this. Calculus AB exam, the exam not open this booklet. Percentage of total grade, 50. This is what, okay. Section 1, Part A, Calculus AB, a calculator may not be used. And then, so we've done all the questions. All these pages are for the questions. There's nowhere that it doesn't mention the answers. That's something I should have checked all the way in the beginning, I guess, but I didn't. Check your work, go to part B. This is part B. Wait, this is bad. Okay, you know what I want to do now is section 2 part A, and then this is section 2 part B. Stop, end of exam. None of these are the answers, right? No, these aren't. Seriously? Okay. So there are no answers on this. Let me quickly Google if I can find one of these. Okay, like if I can find the same thing. What is this called? Random house. So random house AP Calc AB answers. It's a wild shot, but so cracking AP Calculus AB 2018. Practice test 1. Practice. That's the name, right? Practice test 1. So we'll see. Now this is a big moment, right? We need to check if these answers are correct. I don't think this has the answers, but we'll see. AP Calc 1V sample exam. Is this the same thing? No, this is different, completely different. Practice test 1. It might be this. No, I think it's the same 28 questions, right? 28 pages, same thing. So let's check this link then. We'll just keep checking these links and seeing if any of these have the answers. 31. Okay, this might have it. I don't know. Oh no, this is a different test, isn't it? Yeah, this is. Wait. I don't think this is actually. I think we did this one. Wait. This first question seems different, but besides that, it all seems the same. But anyway, this won't have the. Yeah, this is a different test. Great. So, turns out we don't have the answers for this. So, how about this? I'm going to show my answers here. If you get the same answers, that's great. If not, then so I don't know how these answers. Okay, so how about this? I'll also write in the description. I'll just write my answers for each of them, and then you can tell me if you think I got anything wrong. If you want, you can explain why. I'll write them all there right now. Here yourself, you can just check. These are all the questions, right? And I'll also let me guess how many I got right. Right, out of 30. So all these ones, like unless I was very stupid about it, these ones I should have gotten right. The thing is, I've taken similar practice tests before with answers, unlike this one, and I normally think I do very well on them, and then I end up getting like a 70 or 80%, which is not bad, but it's not bad for an AP test, I guess, but it's not good either. It's like pretty low, because I should get 100 on this, right? That's the point. But I really did want to know the answers to some of these questions, like especially that one at the bottom, this one, because I haven't done that. Well, just for this one, let's open up Desmos and see. I'm sure they'll have an answer. Okay, this is definitely an easy one to check. So it's sine of pi over 2 plus x. Okay, let's check this one at least. Sine of pi over 2 plus x minus 1 all over x. As it goes to 0, the limit is 0. So, right, yeah, it is 0. So that's great. We got one question correct that we know of. The rest of these fine. So I want to write these out. If you do it, if you know calculus properly, or if you just at least know some of it, if you can answer any of these and just help me verify, that would be great. But I think that's it then. Let me go back to the stream now. It's been over an hour that I've been doing this. So yeah, this is like pretty long actually. Wait, can you even hear me? I haven't checked that yet. One second. Okay. I think it's fine then. This seems fine. I've done everything. I want to write the answers in the chat. The thing is, I might forget this, so remind me if you have the time. Just remind me of it. And I think that's it then. I've never ended a stream before, so I don't know what to do. I'll just say I'll put this, and yeah. So that's it. If you please make sure to subscribe and share my. Please make sure to subscribe and turn on notifications for more videos. If you enjoyed this video, make sure to give a thumbs up. Remember to any answers that you got for this test. I showed all the questions, so you can just pause and see or find it on your own. Please make sure to let me know of your answers in the chat. And if you enjoyed this sort of video, because this is the first time I've done something like this. Normally it's just me like teaching a concept or solving some videos. Obviously, this shows that I'm not a math expert